Time for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe. And we bumped you from your regular Monday slot this week to focus on farms, which was all very good, but we also robbed you of an opportunity to see something incredible in the sky, or at least at a time many humans would have thought it was incredible in the sky, and now we're all like, meh, what's the latest TikTok video? What did we miss this week, Mr. Universe?
Well, so there is a comet that was recently discovered. It's nicknamed after the discoverer. It's called Comet Nishimura, named after the discoverer, who's a Japanese amateur astronomer who discovered the comet just this past August. And it has brightened up. It is coming close to the sun. Actually, in fact, just September 12th was its closest distance from the Earth, and September 18th would be the closest to the sun. And this is the first time we know that this comet is coming in. But now astronomers have figured out its path, and it looks like it has a period of about 400 years or so.
So we missed it, and we have to wait 400 years to see it again?
Yes, that is correct. But that's at the point. What I was intrigued by, is that, I mean, you know, the weather. It's been raining.
Yeah.
And it was visible in the northern hemisphere, sort of like right in the pre-dawn time. So and it would barely be visible with the naked eye, but certainly with a binocular or with a small telescope, you could see this green-colored comet, and that would have been cool. But I don't know, because it is not clear here. Mm-hmm. And especially in the New England area, you go like, all of these phenomena, oftentimes they go by the cloud side.
Yeah.
So Wednesday, the 14th, that's the day when, I have to actually double check all the dates. The 13th, I should say, the 13th is also one of those days that probably it's not going to be visible in the northern hemisphere anymore. Mm-hmm. It's going to make a pass close to the sun, and of course it's pre-dawn because it's very close to the sun, but then it's going to be visible more from the southern hemisphere on its way back out to the outer solar system. And to me, I was just thinking about it, how comets, the arrival of comets, the detection of comets, has played such an amazing role in human history. And here we are talking about it. Oh yeah, there was a comet that kind of came, that was detected. Oh yeah, by the way, and it's going back out the solar system, and it doesn't matter. Mm-hmm. And there was just a little bit of, maybe it's my age, it's a midlife crisis.
Kids these days don't care about comets like they used to.
It's just this ruefulness in terms of that we are not connected to nature in the same way. And of course, if you and I were having this conversation, say, for example, 500 years ago, we would have to shout very loud to reach a lot of people. So in that sense, I mean,
hear ye, a comet hath arrived.
But anyway, so this comet, it has a green color. We didn't know why some comets have green colors, but a couple of years ago, there was a paper that actually showed sort of that this is sun's radiation that hits the head of the comet, and there are these diatomic carbon atoms or molecule that two carbon atoms combined, and when it gets excited, it actually gives light in the green light, and these diatomic carbon molecules are only in the head of the comet, so the head is green, beautiful, and then you have a long tail which is not green.
That's cool.
So so there are a lot of cool things to say about it. It's a small comet. We think it's going to survive the passage close to the sun, but there is also a chance, because it's small, maybe it will get sort of shattered. We don't know. But
because this is, like you said, just discovered in August, named after the amateur astronomer in Japan who discovered it. What's his name again?
His name is Nishimura, but there is a really cool aspect to it. And astronomers now think there is a small meteor shower in December, and it's called Sigma Hydraids. And usually, but astronomers, the meteor showers are when the Earth, going around the sun in its orbit, passes through leftover dust from previous passage of comets. So we just go through, and those tiny little particles actually burn through the atmosphere, dust particles, and we see them as shooting stars.
That's why we can predict when there's going to be a meteor shower.
That's exactly.
We know when we're going to pass through the Halley's Comet tail,
Right.
and then we can say the Perseids are going to be this time of year because we know that's when we'll be going through some other comet's tail.
And we also know that that's the time to make wishes because, of course,
Yeah.
these dust particles are the ones that make all of your wishes come true.
The shooting stars!
But in this case, they think that this small meteor shower in mid-December is because of passage or dust left over from this comet. And so here is a beautiful prediction and test. If that is true, then we are going to see sort of like brightening up a lot more meteors in mid-December from this meteor shower because the comet has just passed through.
That's cool.
So this is sort of like, here is your own science. Do your own science, doing it.
It's fun because, it's so cloudy, so rainy, we probably wouldn't have actually been able to see the comet all that well this week anyway. But the meteor shower gives us more of a chance, and we're more prepared for it because it's happening in December. But you were saying, Salman, the discovery of comets has led to many other interesting cascading discoveries from some of the most famous astronomers through history.
Right. So, I find the importance of comets, and this goes back to this thing that we are just talking about it. Oh yeah, the comet, yeah, it came and yeah, we didn't see it because it was raining.
Yeah.
Boo-hoo. but actually, historically, they have been crucial. Of course, Shakespeare mentioned it sort of like, in his play Julius Caesar. That's because there is an actual temple in Greece dedicated to Julius Caesar, or it's temple of the comet. And that was because after the death of Julius Caesar, there were games that were held in his honor. And at the start of the games, a bright comet appeared, and his son Octavius, who later on became Emperor Augustus, he said, aha, look, this is the soul of Julius Caesar going to the heavens, and he made him basically divine. And of course, it was good also because he was the son. So
yeah, totally.
Adopted
I hope
son.
my kids believe I'm divine when I'm dead.
Right, exactly. So, and then he dedicated this temple to that, and he minted coins with comet on it. So just think about it, 44 or 42 BCE, and you have coins which have comet on it, and it played, of course, a role in the history of Rome. So here is just one example of it, but more to our point, our relevance to us, is that there was a debate where, from Aristotle's time, or Aristotle's theories, from Aristotle's perspective, there are two big realms. Something that is below the moon, or sublunar, where all the things change, but there is the other realm which is beyond the moon, supralunar, where things are just perfect. That's the realm of the gods. And you cannot have any change because any change from perfection is imperfection. Mm-hmm. So if you are perfect, then nothing changes. So this was the big sort of a cosmological model in some sense that we lived in, that beyond the moon nothing happens. So then, of course, as you can see, comets used to come. You could see comets. Where are they coming from? Well, the idea was that probably those are atmospheric phenomena. Those are not beyond the moon because, of course, beyond the moon things don't change.
Yeah.
And
that's not true, kids. It's Aristotle's view.
That's right.
Yeah.
That's right. Thank you. But Tycho Brahe, one of the Danish astronomers, he observed a comet in the 16th century, in 1577. It was a bright comet, and he measured a distance to that comet through parallax, by the way. This is sort of like, the way to measure distances. And he found that it was at least 4 times the distance to the moon. And he could demonstrate that. And at that time, by that time, Aristotle's ideas were already being thrown out for various sort of like, centuries. People had been looking at that. But this was a pretty big evidence that actually, no, this is beyond the moon. So things definitely change beyond the moon. And then Tycho Brahe's student was Kepler, who figured out the orbits of planets, and came up with the planetary laws. And his data and his observations led to Newton, who came up with sort of like the gravitational theory. And one of his contemporaries was Edmund Halley, who predicted the path of or the reappearance of Halley's, oh, well, he didn't call it the Halley's Comet, but the comet that will return in 76 years, and then it turned out to be what we call Halley's Comet, and the prediction turned out to be just perfect. So again, thinking in terms of that we can see things and we can predict that, hey, you see this thing that is you are seeing right now, it's going to be back in 76 years, and it shows up. That is, in some sense, power of science, power of thinking, but also the beauty of comets.
This comet that we missed this week was just discovered in August. Let's say, hypothetically, there is a comet we're going to discover, but its orbit is directly aimed at the Earth. That would not go over very well. But the dinosaurs experienced this for us 65 million years ago. What's the likelihood that there is a comet that we don't know about that could be on track to destroy us all? Not that we're trying to celebrate the beauty of comets here, but they may be out to kill us.
Well, as they say, like, when it says awful, that is full of awe.
Yeah.
Right? So destruction, I mean, that would be pretty spectacular destruction.
It would be awful. It would be terrific, which would also be full of terror.
So that is one of the problems with comets. I mean, if you think it's a problem, and that is that there are a lot of programs to detect threatening asteroids, and from small ones from half a kilometer up. NASA has a directive to that, and astronomers have been pretty successful in looking at those asteroids that cross Earth's orbit and so on and so forth. Comets, there is always a problem. So of course we know comets that return and things like that, but then there are a lot of comets that come for the first time because they come from the outer parts. The Oort cloud, for example, this is an area where a lot of these comets are. They can be bumped in their orbit and start to come in, or they can have long periods, or like, for example, in this case, it has a 400-year period, but we didn't know that it has come here before. So to your question, absolutely, that can happen. And they can come from any side. I mean, it's not like, hey, let's keep on pointing our telescope in this direction. No, they can be coming from any side, including from behind the sun, for example, like on that side, which would be harder to detect. So people do try to look for it, but are we 100% sure this is not going to happen? No. That can happen, and hence you have movies that actually don't look up, or for example, before I think not Armageddon, but Deep Impact. I mean, so you can have potentially those type of scenarios. But again, I would put it in that context that comets have also brought potentially water, although asteroids have also brought water. They also have organic compounds, also ingredients for life, sort of like, amino acids and other kind of complex molecules that are essential for life. So their impacts on Earth have not always been just bad. In fact, we may be talking about it because comets crashed on Earth. But if they crash now, we won't be here. But whether that's a good thing or not, that depends upon who you ask. Because, no, I'm going to go on this rant right at the end, because, I mean, what we are doing to the environment, what are we doing to the other species? Would most of the other species send a thank you note to the comet? Maybe they will. So, sorry, I just got distracted by that stuff. But no, but that can happen. And I think, but I don't think we can do much about it at the present time.
Okay.
But this one is not only going to not crash here, but now you can't even see it.
Not for another 400 years.
Unless you go to the southern hemisphere by next week.
Okay. Plan a trip.
Plan a trip.